Okay, we'll come back to how to put that in there. Those are some, he's going to go into some tricks into storing the numbers in the calculator. I'm going to go back, though, to these videos in a little bit. But I want to go here first, and let's talk about what he's trying to show. First off, on your paper, and the first thing you're going to need to do is we need to graph these lines. And the first thing I'm looking at is that both of these are already in y equals form. So the first thing we'll do is we're going to graph the y-intercept of the first problem. So I'm going to go up here to 9, and right now I want you to put a dot on your y-intercept. I want you to put it at plus 9. The slope right here is -1, right? Because it says negative x, but negative x is the same as -1. Anytime you have a whole number, you put it over 1. The top number, it's negative. It's telling you to go down 1 and to the right 1. So I'm going to go back up here. I'm going to start at my y-intercept. You go down 1 to the right 1, put a dot. Let's go back to my dot here. Do it again. Down 1 to the right 1, put a dot. Down 1 to the right 1, put a dot. Down 1 to the right 1. Now, this is where I was being picky, saying you're graphing. You want to make as many dots as you can and not just sketch a line, because this is important, because we're trying to find the solution is going to be the one spot where the two lines intersect. Remember, you can also go backwards and go up 1 to the left 1 and put a dot. Okay, I'm going to leave this alone for right now. I'm going to go down to the next problem. It says my y-intercept is -3, so I'm going to go down here to -3. My slope now for this one is 2. And it's 2 over 1, because remember, any whole number is over 1. It's going to tell me to go up 2 to the right 1. So I'm going to go back up here. I'm going to start at the dot. I'm going to go up 2 to the right 1 and put a dot. I'm going to go up 2 to the right 1 and put a dot. Up 2 to the right 1 and put a dot. I do it again. Up 2 to the right 1. Ding, 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 ding. Look, the two lines intersected. Up 2 to the right 1. Right here, it intersected at this point here. Well, what is that ordered pair? 1, 2, 3, 4. 1, 2, 3, 4, 5. My solution is 4, 5. Now, you're going to want to check that. Oh, where's my calculator? There we go. I always forget to turn that on, and I think I say that every time. Okay, so we're going to go in the calculator, and I want you to go to y equals, and I want you to put in there -x plus 9. And I want you to go down to y2 and put in there 2x minus 3. Okay, you put them into y1 and y2. First thing I want you to do is press graph. I want you to make sure that you graph the two lines correctly. Are they going in the right direction? Do they look like your picture? Yes, they do. Now we can check in two different ways. One of the ways that the video showed you was they went to second, trace, 5 for intersect, and enter 3 times. That right there says 4, 5. That's my solution. It's showing where the two lines intersect. The other way you can check it is by going in the table, second graph, and go down to where 4 is, where x is 4. And you want to see, is y1 and y2, are they the same numbers? They are, so that means that we are correct. Let's go to the next one. First thing we're going to do is you're going to plot the y-intercept at -1. So I'm going to go down here to -1 and put a dot. My slope is -2. That's -2 over 1. It's telling me to go down 2 and to the right 1. So I'm going to go back here to my dot. I'm going to start at my y-intercept. I'm going to go down 2 to the right 1 and put a dot. I may have to move this down here. Do it again. I'm going to go down 2 to the right 1 and put a dot. Now I'm going to go backwards as well. I'm going to go up 2 to the left 1. I'm going to go up 2 to the left 1. Okay, I'm going to stop for right here for just a second, and I'm going to go back to my other problem, my other one, which is x plus 5. So I'm going to go to plus 5, put a dot. What's my slope in this case? All it says is x. There's a 1 in front of it. So it's 1 over 1. Tells me to go up 1 to the right 1. Well, if I go over here to graph and I go up 1 to the right 1, I put a dot. I can keep doing that, but the problem is I need to see where the two lines intersect. I need to go back the other way. So I'm going to go down 1 to the left 1, down 1 to the left 1, ding, 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 ding. I hit the line. I could stop right there. So right here looks like it's my ordered pair, which is negative 2 and up 3. So I think my solution is negative 2, 3. You need to make sure you go back to that calculator and double check. That's going to be a big deal. You've got to make sure you check all your answers before you turn it in. This way you make sure you get this. This is standard 4.1a to make sure that you can solve by graphing and calculator. Okay, minus 1. Go down here to y2. I have x plus 5. Remember I said to press graph first. Make sure you graph them correctly. Now, second trace, 5 for intersect, enter 3 times. It says negative 2, 3. Now I want you to make sure you're in the habit of looking in the table, because they may give you a problem that gives you the table and you have to be able to look and see and find your solution. And you're looking to see right up here where the y1 and y2 are the same. And that's how I know I'm correct, because I have negative 2, 3. Let's do the next one. First thing I do on the next one, I plot that y-intercept. What is that y-intercept? It is 1. So I'm going to come over here. I'm going to put a dot on the y-axis on 1. My slope is 2. So I'm going to put that over 1. It is positive. It tells me to go up 1 and to the right 1. So from here, I'm going to start at my y-intercept, go up 2 to the right 1 and put a dot. Again, up 2 to the right 1, put a dot. Up 2 to the right 1 and put a dot. Here I can go down 2 to the left 1. Down 2 to the left 1. Okay, so now I've got my line. The next thing I have is plot the y-intercept at negative 3. Let's see here. So I'm going to go down here to negative 3. My slope on this one is 1/3. That's telling me to go up 1 to the right 3. So right here I'm going to go up 1 to the right 1, 2, 3. Go up 1 to the right 3. Well, I'm not really going the right direction, so let me try and go backwards here. Down 1 to the left 1, 2, 3. Down 1 to the left 1, 2, 3. Now wait a minute. Something that isn't crossing right here. Let's see. Let's go down here and go down 2 to the right 1. Now they're crossing, but something's not going on right. Like it doesn't look like it's hitting in an exact spot. Well, let's look and see. Let's go on our calculator and see if I made a mistake, or if maybe it's a decimal answer. We'll go up here and we're going to put 2x plus 1 in y1, and 1/3, 1, remember it's 1 divide 3, x, oops, no, go back, hello, x minus 3. I'm going to press graph. Well, looks like I got it right. Second trace, 5 for intersect, enter, enter, enter. And that's what, look, because see, they intersect, but they don't intersect in an exact point. They intersect at a decimal. So what does it say? It says negative 2.4. Negative 2.4 and what was that other one? Negative 3.8. Now, here's why I like using the 3 wishes. Because, or I call it the 3 wishes where we press second trace. Because if I look in my table, they're all whole numbers. I'm not going to find the exact spot where y1 and y2 are the same. The only way you can find your solution right here is by putting it in the calculator and doing second trace and 5 for intersect. That's the only way you can find that answer, unless you know the exact decimal. Okay, number 4. First thing we're going to do, plot the y-intercept at +2. My slope on this one is 3, which is 3 over 1. Tells me to go up 3 and the right 1. So I'll start here, and I'm going to go up 1, 2, 3 to the right 1, put a dot. Up 1, 2, 3 to the right 1 and put a dot. Now let's go down 3 to the left 1. Down 3 to the left 1. Well, if I go over here to the next one, I start at -3, and this slope is -2, which is -2 over 1. Tells me to go down 2 and to the right 1. So I start here, and I'm going to go down 2 to the right 1 and put a dot. Well, it's going backwards. Let me go the other way. Up 2 to the left 1. Ding, 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 ding. All right, I found the intersection. I'll go ahead and just do it a little bit more there. All right, so here is where they cross. Looks like -1, -1. That's what I think my answer is. So when I go back up here to the calculator and go to y equals, I'm going to clear those out. In y1, I'm going to put 3x plus 2. And in y2, I'm going to put -2x minus 3. Remember, press graph. Make sure that they are looking the same. Okay? They do look the same. I'm going to go second, trace, 5 for intersect, enter, enter, enter. -1, -1. Sure enough, there it is. Make sure you know how to find it in the table as well. Some people are not understanding. They think, oh, I'm just going to do it the one way. Well, I'm telling you, they're going to have some questions where you have to find it from the table. I know that this is the right answer because y1 and y2 are the same number. So then you take the x number and the y number. Okay, number 5. Number 5, we're going to go, oh, wait a minute. I got a problem. Houston, I have a problem. Right here, can I graph it right there in that form? That's standard form. How do I need to move that? I need to move it into slope-intercept form. So down here in the space, let's rewrite. We got to rewrite this. And we need to go and we need to add x to each side. That's what they were starting to talk about in that video. Y equals x minus 4. All right, so there's your equation. It's in y equals form of what you need to graph. I start with the y-intercept at -4. What's my slope now? It's a positive 1, telling me to go up 1 and to the right 1. So here, I'm going to go up 1 to the right 1, put a dot. Up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. All right, I'll see if I need to do, I think I have to do something else in just a second. On the second one, what is the y-intercept? Where are we supposed to start at? It doesn't have a number added or subtracted at the end. You need to start at the origin. You need to start at 0. Now the slope of this one is 2, which is 2 over 1. Tells you to go up 2 to the right 1. Well, let's see. Up 2 to the right 1. Up 2 to the right 1. Let's go backwards. Let's go down 2 to the left 1. Let's try that way. Down 2 to the left 1. Down 2 to the left 1. All right, now let's see if my blue line, let me go backwards again. It was down 1 over 1. Let's add some more dots on here. Looks like I got to keep going and going and going. Am I ever going to cross? The next one? All right, so then this one I'm going to go down to, oh, ding, 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 ding-a-ling-a-ling. Just kidding. Okay, right here, I have -4, -8. Okay, so now when I go in the calculator to go check, I go to y equals. We need to put in there x minus 4. And in y2, We just put 2x, press graph, make sure our graphs look the same. They sure do. Second graph, I'll go to the graph or the table first. Look, y1 and y2 are the same. It means I'm correct. Or I can go second trace, 5 for intersect, enter 3 times. Okay, and your answer is -4, -8. Let's skip for a second and go to the other problems. Let's go to number 9. Okay, right here, 9 through 14. Let's try and figure out what our solutions are here. Now, I do want to go back a sec and talk about the types of solutions that we have. Nice graph. Good job, Crawford. Okay. First off, what we've been doing is we have 2 lines, and they intersect at one spot. This means that there is one solution. And when there is one solution, you write that as an ordered pair with the x and the y. But if I have 2 lines that are parallel, that never touch each other, there is no solution. So when they ask you for the solution, you write none. So you don't write an ordered pair. The other type of line that you have is when there's only one line graphed. When there's only one line graph, that's the 2 lines that are laying actually on top of each other. Nice, I can't draw a straight line. And there is infinitely many solutions when there's only one line because of the same line. So right here on this one, I want you to put a dot where the 2 lines intersect right there. That is your solution. It is 1 and up to 7. So the x number is 1, so it's 1, 7. Number 10, put a dot where the 2 lines intersect, right there. What is that point? -4, -2. Number 11, right there. If I told you to put a dot where the 2 lines intersect, do they intersect? Do they touch each other? No, they're parallel. So there is no solution. So you just write none. The next one, put a dot where the 2 lines intersect. That ordered pair right there is you go over 4 and up 2. So your solution should be 4, 2. "13. Do the 2 lines intersect? Yes, they do. Let's put a dot where they intersect. What is that ordered pair? I go to the left 4, so that's -4. Oh, my pen's freaking out here. -4 and +2. If I told you on number 14 to put a line where the 2 lines intersect, do they? No. They're parallel again, so there's none. Okay, for those of you that weren't paying attention, they're parallel lines, and so parallel lines never intersect, and you just write none. Okay, the summary portion right here. A blank is a set of 2 or more linear equations containing multiple variables. A system is a set of 2 or more linear equations containing multiple variables. A solution to a system of equations is an ordered pair that satisfies each equation in the system. It will make both equations true. A system of equations can be used solving 3 different methods. One method is going to be by graphing. Okay, graphing is going to be the same. We're going to put calculator in there as well because what the calculator is doing is graphing it. Another way is going to be substitution. We'll be doing that next. The third way, which is what we'll be doing after our break for the next set of Unit 4, is by what's called linear combination. Those are going to be the three ways that we're going to learn how to solve systems of equations. When using the graphing method to solve a system of equations, the solution is the intersection point of the two lines. Next. To graph a system of equations, both equations must be in, oops, not y, slope intercept, sorry, should be in slope intercept form. What does that mean? What does that look like? That means that it's y equals mx plus b. Remember, because you have your y-intercept, and then the m is your slope, just like we were just graphing them. Two lines that have the same slope are called parallel lines. When graphing a system of equations, intersecting lines with different slopes will have one solution. The example, all they want you to do is kind of sketch your axes and draw where two lines are intersecting. And let's put a point right there, just like I did on my other picture. Remember, this is the x and the y. That's what you're looking for. When they have different slopes, it means they're going to intersect. A system of parallel lines have no solutions. Your example for that one, let's see, I'm going to draw my line here, make them nicer. There we go. Okay, parallel lines have no solution because they do not intersect. Oh, no. A system that has coinciding lines have blank solutions. Well, what the heck does coinciding mean? It means that they're the same line. Okay, so right here, let's put on here that they're the same line. And that means that there's infinitely many solutions. What that's meaning is, like, when you have two equations, I'll give you an example in just a sec. Let me draw my line. Okay. All right. So for example, say they gave us one of the equations like this, and the other equation was written, okay, and they say graph these two lines. Well, if I took this one right here and solved for y and I moved x to the other side, it would be y equals 2x. Well, aren't these two equations exactly the same? It just means that after we solve for y and we put it into slope-intercept form, they'd be the exact same lines. All right. Let's go back a sec and go ahead. Which one did we stop off on? Number 6? Did I skip number 6? Okay, go back to number 6 and let's graph that. Sure did, number 6. Okay, let's practice this again. First thing we do on number 6 is we plot the y-intercept, -1. So I'm going to put a dot down here at -1. What's the slope in this problem? 3. Well, how does that tell me to move? Up 3. Now don't just say over. It's got to go to the right. Okay, the way we're doing it. All right, so I'm going to grab my dot here. I'm going to go up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Now let's try going backwards. Down 1, 2, 3 to the left 1. I'm going to stop here. I'm going to see what happens with my second one. So where do I start? Where's my first dot go? At +3, right? So I'm going to put that here. Now what's my slope for this one? It just says x. It's 1 over 1, so it's up 1 to the right 1. So I'm going to start at my y-intercept, up 1 to the right 1, up 1 to the right, ding, 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 a-ling-a-ling. Okay? The two lines intersect, there they are, right there. 2 and 5 is what it looks like. So if I go in the calculator, just kidding, calculator. Hey, did I tell y'all my joke? Do y'all know how farmers keep track of their cows? No, they use a calculator. Oh, wow. Yeah, that was good, wasn't it? That was good. You know, a calculator? That's how they keep track of their cows. Okay. Now we go down there, Y1 and Y2. I didn't say I was real good at it. All right. I am so hilarious. Now I'm going to go second trace, 5 for intersect. Let the lines graph before you do anything else. That'll, if you don't, you'll freeze it. And now it says 2, 5. Yeah, buddy, I got it right. So let's move on. All right, next one to graph. Make sure you're on that the back side of the paper. I plot my y-intercept at -3. What's my slope? 1/2. That tells me to go up 1 to the right 2. Hey, I can already tell what's going to be the solution right away. Can anybody tell? How do you know by looking at the equation that they're going to be parallel? They have the same slope, but the what? But different y-intercepts. So we should know that if they have the same slopes but different y-intercepts, they're parallel. And if they're parallel, that means they're not going to intersect. So I'm graphing them because you are going to have to make sure, part of the standard is making sure you can show me that you can graph. I know that my two lines are parallel. They're not going to touch, so there is no solution. Okay? Let's look at number 8. Okay. Can I graph these the way they are right now? Nope. I've got to solve for y. So the first thing I'm going to do here on the first one is I'm going to subtract x from each side. I get 3y equals -x plus 3. I'm going to divide by 3. I get y equals, well, what do you do with this? It is a fraction. It is -1/3 x, and then 3 divided by 3 plus 1. So let's graph this one. I'm going to start at +1. How does my slope tell me to move? Down 1 and to the right 3. So I'm going to go here, grab my dot. I'm going to go down 1 to the right 3. Down 1 to the right 3. Down 1 to the right 3. I can also go backwards. Up 1 to the left 3. Up 1 to the left 3. All right, now, I can't graph this other one yet either, though. I have 3y equals x minus 9. What do I need to do before I can graph? I need to solve for y. Divide by 3. Okay, so I get y equals, now what is x divided by 3? It is 1/3. And then -9 divided by 3 is -3. Now some people, oh, I didn't put my x on there, did I? Golly gee willikers. Okay. Now, some people will tell me that these two lines are parallel. Because they'll look at the equations and think that they have the same slopes. Do they have the same slopes? This says 1/3. Positive, so I have to go up 1 to the right 3. So let me go over here. Let me start at -3. And I need to go up 1 to the right 3 and put a dot. Up 1 to the right 3. Ding, 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 ding. Dong. Up 1 to the right 3. The two lines intersect right here. And I have 6, -1. Okay? Then you would check it in the calculator the same way. Hey, does anybody know why Tinkerbell stepped on Tigger's foot? Because, yeah, I know, I went to Disney World. I got lots of jokes now. Because Tinkerbell did not step on Tigger's foot, Tinkerbell stepped on Tigger's foot because she didn't want to step on poo. Ba-bump, bump. All right. Now, look at this one for a sec. It says match the 3 views of this solid. So look at these figures. Let's see if I can make this smaller here so we can see it. Don't tell me, but I want you to take a second. Do you think you can figure out which one this is? These are the sides, and which one of these figures would it match? So take a minute and try and figure it out. Okay. Again, we said don't say anything. This one, which ones can I eliminate because of this figure right here? J, because J has a slant on it, right? Oh, hello. There we go, a slant. So that doesn't work. J, go away. Okay? And G. So now I've got these two to figure out. Now, this would be, looks like the top side, right? So the answer should be F. For failure. That's always positive. Okay? We'll come back. Now, let's look at this one. Let's start. Oh, hello, pin. All right. There's 2 of these we want to do because we're going to have an SFA coming up, so let's look at this one. A telephone call from Richmond to Monterey costs 25 cents for the first minute and 10 cents for each additional. They give us the equation. It can be used to determine the cost of the phone call between the 2 cities. What is the independent and dependent quantities? First off, do y'all remember what's independent? Which letter? X. What is dependent? Y. Okay. What are the things they're talking about? Oh, and it says respectively. What does respectively mean? It means to give it to them in this order. So they want you to do whatever the independent is and then the dependent. Independent is the X. What is being used for this X? The what? The minutes. Because it's 10 cents per minute. Okay, so let's see which one says minutes first. That one says cost. Nope. Telephone, that's not even part of the problem. And the dependent is the cost. So the only answer choice we have is A. But that, you're going to have to remember right here what respectively means. Next, the last one. Right here it says, which is always the correct conclusion about the quantities of this function. Now, when you have an equation like this and it's asking you what is always correct, that means if you can find one thing that says it's wrong, then that's what you need to eliminate, even if it's just one thing. So you need to test it all out. So I'm going to go in here and I'm going to put x plus 4 in my calculator. Anytime they give me an equation, I always go in there and put it in the calculator and be able to use it to look at things. The first thing says the variable x is always 4 more than y. Let's look at the table. Is this x number right here, -4, is that 4 more than the y number? Is -4 more than 0? No. If that's hard for you to figure out, look down here. Is 1 more than 5? No, it's not. So it's not A. The next one says, when the value of x is negative, the value of y is also negative. Well, look, x is negative. Is y negative? Nope. So it's not B. It says the variable y is always greater than x. But some people will tell me that -1 is not bigger than -5. It is, because it's more to the right. Your answer in this case should be C. You would have to go through and eliminate each one individually.